Hello students, today we will discuss indifference curve analysis. It is also called ordinal utility theory or ordinal utility approach. In this topic, in this theory, we assume that we can give orders to commodities, or we can give orders to bundles or groups of commodities. Utility we are getting out of this. We can give order or ranks only. As previously we assumed that we can measure utility cardinally, in numbers like 1, 2, 3, 4, and it was criticized. So this theory is more close to reality. It is more real that we are only giving ranks or orders. Means if some commodities are there, you can tell that you are getting maximum utility from A commodity, then lesser from B, then lesser from C. So you can give ranks to these commodities according to utility you are getting from these commodities. As I told you that topic's name is indifference curve analysis. Why this is indifference curve is used in heading of this chapter? Because we use very important tool of economics in this analysis, and that is called indifference curve. Not only in this topic, but in various topics like deciding about investment, and even in theory of production we use this type of curve. These are very important tools we use in this approach. One is indifference curve, another tool is a budget line. Budget line is also called price line. So these are two very important tools we will be using in this analysis. So first of all, what is indifference curve? Indifference curve shows various combinations of goods providing same level of satisfaction to consumer. Okay, so it means this is a curve and every point on this curve shows equal level of satisfaction. So now we will discuss about indifference curve. Okay, as you know, this is combination of two commodities. So one commodity we will take on OX axis, another commodity we will take on OY axis. So indifference curve shows various combinations of two commodities. So let me draw indifference curve first. So here is our indifference curve. If we see various points on this curve, you can see that these points show you various level of Y and X. Suppose we are consuming X commodity and Y commodity. Okay, you can take any other examples like food, cloth, bread, any example you can take, or A, B, C, D, you can use such variables. Okay, so you are consuming this much of X on this point and this much of Y. So this is a combination of X and Y commodity and you are getting some satisfaction out of this. Now we will compare this point with another point on same curve. By the way, this is indifference curve. This is indifference curve. So we are taking one more point over here. So this point also shows some X, this much of X, and some Y. I mean this much of y. So again we are taking this much of x and this much of y on this point, and satisfaction which we were getting from this point and from this point are equal. How it is possible? If you see, if we are increasing consumption of x, we are decreasing consumption of y. So there will be some addition in our utility because of more consumption of x. So we will reduce consumption of y to decrease our utility so that we can reach on same level of utility or satisfaction. Similarly, you can compare one more point over here. On this point, you are taking this much of x, I mean this much of x you are consuming, and you are consuming this much of y, this much of y you are consuming, and again on this point satisfaction is equal to this point and also this point. So this is your indifference curve. Okay, what is indifference map? If I draw more than one indifference curves, this is called indifference map. Okay, so it was about indifference curve. This is very important tool used in economics. Its slope is also very important. So now we will talk about its slope. As you can see that as we are increasing consumption of x, we have to reduce consumption of y. So there is inverse relationship between x and y. So its slope is negative. Obviously its slope is negative when you are moving from this point to this point. You are increasing consumption of x and you are decreasing consumption of y. You can also say that you are substituting y with x as you are moving from this point to this point. So if you are substituting y with x, obviously you are doing in such a way so that your total satisfaction remains same. That is the definition of the indifference curve, that it shows only those combinations which provide same level of satisfaction. So when you were consuming 1x, suppose you were consuming 5y, suppose. Now you have increased level of consumption here. So now you are consuming 2x. So there will be decrease in consumption of y. Suppose this consumption is decreased by suppose 1.5 units. Again you are increasing a consumption of x. Again you are sacrificing some y. Again you are increasing consumption of x and you are sacrificing consumption of y. If you see, this line is longer than this and this is longer than this. Every time you are increasing consumption of x by 1 unit, so this distance is equal here, but this distance is decreasing. Initially you were giving up more than 1 y for 1 x, then near about 1 y, and now you are giving up less than 1 unit. If you compare, if this is 1.5, this is 1, then this is somewhere 0.6 or 0.7. So every time when you are increasing consumption of x, you are sacrificing some y, and the amount you are sacrificing of y is decreasing. So you can say that the rate at which you are substituting y into x, this rate is decreasing. This rate is called marginal rate of substitution. This is called marginal rate of substitution. And how to measure marginal rate of substitution? Change in y due to change in x. As you are increasing consumption of x, you have to decrease consumption of y. This is 1 every time. This is 1. But this was, earlier it was 1.5, then near about 1, then near about 0.6. So every time whatever you are sacrificing of y so that you can increase consumption of x is decreasing. So you can say marginal rate of substitution is decreasing. So marginal rate of substitution is the rate at which you are substituting y with x, and this rate is decreasing. One more interesting point here is that marginal rate of substitution, which is decreasing, is slope of your indifference curve. Yes, this is slope of your indifference curve. When I am saying while moving from this point to this point, your marginal rate of substitution is decreasing, actually I am saying that slope of indifference curve is decreasing, because marginal rate of substitution is also slope of indifference curve. We will compare slope on this point and on this point. If we draw a tangent here and also on this point, so you can compare the slope. Slope is more on this line and slope is less on this line. So as you move from here to that side, slope of indifference curve is decreasing, and slope is also called marginal rate of substitution. So we can say that marginal rate of substitution is decreasing. So indifference curve is a very important tool we will use in this topic. So let's talk about its properties. So here you can see properties of indifference curve. First point is slopes downwards, slopes negatively. As you know, when we draw indifference curve like this, its slope is negative. If we increase x, y will be decreasing. So this is called negatively sloped. Next is convex to origin. Okay. First point was slopes downwards, or it is negatively sloped. If something is like this, it is negatively sloped. If something is like this is called positively sloped. So now we are talking about convex to origin. Okay. So when we are saying it is convex to origin, actually we are indirectly saying that marginal rate of substitution is decreasing. Same things are there, like this is convex to origin. It is bent towards the origin point. You can see it is bent. It is bent towards origin. So because it is having this shape, to convex to origin, just because of that its slope is decreasing, and just because of that marginal rate of substitution is decreasing. Suppose if indifference curve is like this, it is not convex or concave, it is a straight line, and if suppose in some particular case we are having this type of indifference curve, our marginal rate of substitution will be constant. It will neither increase nor decrease. So When our indifference curve is like this, marginal rate of substitution is decreasing. I mean to say its slope is decreasing. If indifference curve is like this, marginal rate of substitution is constant and its slope neither increasing nor decreasing. It is a straight line and slope is constant. If suppose this is a rare case, usually we don't draw it like this. Suppose if indifference curve is like this, marginal rate of substitution will be increasing in this situation and it is concave to origin. This shape is called concave to origin. So the actual shape of indifference curve we assume is this. Only in exceptional cases shape may be different, otherwise this is the original shape of indifference curve. So it is negatively sloped, it is convex to origin. These are two properties we were talking about. Next is